Hey everyone, welcome to CodeAnanta. Today we are going to solve uh, one of the popular LeetCode question to some. And first we analyze the problem, and then after we understand the intuition behind the problem, and after that we write the code also. Okay, for this question, uh, for this question, the question say that question problem statement say that problem statement say that we are given an array, nums, and integer target. Return the indices of two numbers such that they add up to target. We are returning those indices of element. The sum are equal to target. Okay, we may assume that each element, each input would have exactly one solution. This means to each test cases has one solution. We have to find one solution only. You may not use the same element again. This means we are using 2. Again, we are not going to use 2. We have to move ahead. We'll have to move ahead with 7. With 7, 11, and 15. That's what full statement says. You can return the answer in any order. Likewise, 2, 7 indices are 0 and 1. uh, 2 plus 2 plus 7 is equal to target. So we'll return what? We'll return 0, comma 1. So you can also return what? 1, comma 0. There is no constraint in order. Okay, I think you got this. I think you got this. So we move ahead. We'll go to move ahead in the question statement. And the first test cases, for the first test case, you can see 2, 7, 11, 15, and target is 9. Target is 9. We were going to see the each possibility like 2 plus 7 is equal to 9, which is equal to target, our target, which is equal to our target. So, so we can return we can return what? Those indices is 0 comma 1, so we can return it 0 comma 1. And the second test cases, you can see that the second test case 3 comma 2 comma 4, and this is the array, this is the array, our array, and target is 6. So we go through the each combination. 3 plus 2 is equal to 5. Is this number 5? Is this number equal to 6 or not? No. Is this not equal to 6? So we move ahead. We go to the next element. What is the next element? 3 plus 4. 3 plus 4 is equal to 7, which is which is equal to target or not, which is not equal to target. So we move ahead. With the next element. Next element is 2 plus 4 is equal to 2 plus 4 is equal to 6, which is equal to target, our target. So we can we can return those indices 2 or 4. What is the index of 2 or 4? 2 or 4, 1 comma 2. This of this. For the next test case, we can see ARR of ARR is equal to 3 comma 3. The target is target is 6. So we go through the element each element. 3 plus 3 plus 3 is equal to 6, which is equal to our target. So we can return, we can return 0 comma 1. You can also return 1 comma 0 also, because order doesn't matter here. Because the question statement says you can return answer in any order. So we move ahead for the brute force approach. First, we are going to solve with the brute force approach, and after that, we optimize approach also. We discuss optimize. We will discuss optimize also approach also. Okay, check this test case for our explanation. Take this for our explanation. This is our array. This is our array, and the target is 9. 9. And the target is 9. So in the brute force approach, we are going to check all the possibilities for this test case, for the possibilities of the test case. Okay. 2 plus 2 plus 7 is equal to 9. After the first test case, it's achieved its target. It's achieved its target. So you can return. Return it what? 0 comma 1. So we are going to see also another test case. I'll give you the test case for this. We give you the test case for this. ARR of 3 comma 4 comma 9 comma 2. Okay. The target is 6. Target is 6. The target is 6. Okay. For this, we are going to check each possibility. 3 plus the next element. Not we are going to choose the same element again. So we are going to choose only next element, like 4. 4 is equal to 3 plus 4 equal to 7, which is not equal to 6. Then it's this number. It's this number. Okay. Then 3 plus 9 equal to 12. Is this number equal to 6 or not? No. Is this number not equal to 6? Is this number not equal to 6? Then we move ahead. Okay. Okay. 3 plus 2 number equal to 6. Is this number equal to 6 or not? Not equal to 6. We move ahead. 4 plus 9. Is this number is equal to 6 or not? No, not equal to 6. And move ahead. 4 4 plus 2. Is this number equal to 6? Yes, is this number is equal to 6. So we can return those indices. Indices is 1 comma 1 comma 3. I can return it. This is our answer. So I think you got my point. What I'm trying to say, what I'm trying to say. We are going to write pseudocode also for this. For int I is equal to 0 I in I plus plus, and for int j is equal to I plus 1, j is equal to n j plus plus j plus plus. For the each element, we are going to check. You are using two loop for each element. Using two loop and check the condition. Error of I plus error of j is equal to target. Equal to target. If this equal to target, if this equal to target, you can return those indices I, comma j. If it's not, you are not find the element, you are not find the element, you can return empty vector. So this is our pseudocode. Pseudocode. Let's go to the lead code and solve the problem by brute force. Okay. For the brute force approach, int n is equal to error of the size, and for int I is equal to n I plus plus, for int j is equal to I plus 1, j is less than n plus j plus plus if error of I plus error of j is equal to target, equal to target. So we can return I, comma j. I think you got my return empty vector. So this is our brute force approach. I hope this will pass all the test cases. Okay. It's passed all the test cases. I think it's submitted. This will submit. Okay. Submit the code successfully. So we are going to talk about its time complexity. What is the time complexity it has? Okay. For this for this loop, it take O of n because it run till n. Okay. For this, it takes O of n. Overall, the time complexity the time complexity is, we discussed time complexity in the later video. I'll I will upload another video for the time complexity also. The time complexity, the time complexity of this brute force approach, the time complexity of this brute force approach is equal to O of n square. The space complexity O of n, O of 1. Okay, by mistake. Okay, O of 1. We are going to see and talk about optimized approach also, in which we are going to learn HashMap. What is HashMap? Uh, In our further video, we'll also I will uh, teach the map also. For the brief, I can tell you. For the brief, I can discuss with you for the optimized approach. For the optimized approach, we are going to take uh, map. For the optimized also, we are going to take map. We are taking this array only. Copy this. Test case. Okay. Uh, map is what? Map is map is map is data structure. Data structure. Map is data structure which is form key value key value pair key value pair by which you can we can we can find the frequency and many other things. We can do the many other things also. Okay, do the many other things also. Okay, hmm. And the target is 9. Target is 9. So we create the map. We create the map. We create the map. Hmm. We create the map. Start. Uh, for the two int. Some of the cumulative term int cumulative sum is equal to target minus 2. What is 9 minus 2 equal to 7? Is this C7 number we seen in map ever or not? No, because 9 minus 2 is equal to how many number we are required to make 9? 7. 2 plus 7 equal to 9. We have already 2. 9 minus 2 equal to 7. Is this 7 is seen in map or not? No, we don't seen in we didn't seen in map. Okay, so we didn't seen in map. So you can didn't seen in map. You can store 2 with index 0. Okay, or we move ahead, and when we move ahead, cumulative sum is equal to target target minus 7 target minus 7 9 minus 7 equal to 2. we seen we seen we seen previously in map or not? 2 is seen previously in map or not? Yes, we seen in map. So 2 is seen in map or not? Yes, is seen in map. So remaining is 2, and 2 plus 7 equal to 9. That's why we can take. That's why can previously see or not. That's why we can take. We can return here. We can return what? Map of cumulative sum comma I. We can return for this. We can see also other test case. for the better understanding, copy and paste here. And here we are going to make a map, one map. Okay, okay. You see one map, and we are going to go through the each element. Our cumulative sum. Cumulative sum is target, target minus 3. Target is 6 minus, we have 3. Minus is minus 3 is equal to 3. We, uh, 3 is seen before in map or not? No, there is no 3 in map. We didn't see in map. That's why we know. We move ahead for the next question. Next element. 3 is after target is 6. Equal target is 6. Or so target is 6 minus 3 is equal to 3. We want to 3 more. We want to 3 more to fulfill the to fulfill the target value. So that's why we seen in previously or not. We not don't see in previously. So we can move ahead for the next element. Cumulative sum. Cumulative sum is equal to target minus 4 equal to what element? 6 minus. Okay. One thing also you have to remember. You have to remember. You see 6 minus 3 is equal to 3. Is not equal to in map. It is not in map. So we add them into map. 3 under 3 arrow. Its indices. So for the next element, 6 minus 4 equal to 2. We've previously we've previously seen or not in map 2. No, we don't see in map. So, remaining, we need, we need 4. We need 4. 2 is not seen in map. So, you can add 2, you can add 4 with indices. Okay, for the, we move ahead until we find the answer. We move ahead. Target, target minus 9. So 6 minus 9. Obviously, this is not, minus is not present in map previously. Previously, we look up in, look up in map. Target is not. No. Obviously, this is not. Cumulative, we will move ahead for the next element. We are going to store also for this number also. 9, 9 indices with indices, index 2. Okay. For the next element, we have target minus 2 is equal to target minus 2, target is 6 minus 2 equal to 4. 4 is this number we 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 have we have seen this number in map already previously with this number already seen this number previously. So so 2 plus 4 is equal to 6. We can return here what we can return map of, we can see here can see here. Here, 4 is present. 4 is present in map. We need only 4. Is this present in map? Yes, we can present in map. We can return what? Map of cumulative sum. Cumulative sum. That why cumulative sum? Cumulative sum, that is target. That is the target. Cumulative sum. Why cumulative sum? 4. Map of cumulative sum means they find the indices of that previously stored in a map. Okay, and the I, the current element. Okay, we can return. This is the idea we have to. I want to solve this. Okay, we are going to solve. We are going to solve. We are going to write the code also. So I will explain line by line through code also. Okay, okay. For the optimized approach, uh, T minimize. We take the another map also. Here of dot size. Unordered map int mpp int I is equal to 0 int n I plus plus int cumulative sum is equal to target minus ARR of I. Okay, we find the remaining element. If the remaining element, if the remaining element, you can also say remain. It's more understandable. So it is more understandable. Remain. Okay. MPP dot find remain with this element find in array. If find this array, if find this element in our map, you can see that sum is exist. We can say that sum is exist. Okay. Cumulative sum, no, remaining, I. Okay. And return after empty. You can also, one thing, don't forget to add that element. Don't forget to add in map of that element index. Okay. I hope this problem pass all this solution all pass all the test cases. Submit it. Yes, we got the answer. We got the answer. You can analyze. Now we are going to understand the time complexity also. For the time complexity, it take because of we are using only one loop. We take time complexity O of n and space complexity. We are using map. That's why O of n. So that's why O of n. That's all for today. Today question. If you find this helpful, make sure to like and subscribe to my channel. Okay. See you in the next video.